Hello, welcome to Science Tube. Like I stated earlier before this time, I explained the word homologous series. I said it is a series of compounds that follows a regular trend of which successive members differ by a CH2 group. That is the word homologous series. Differ by a CH2 group. I have series of homologous series. We shall begin today's section with the first one we call the alkenes. Alkenes. The alkenes are group of organic compounds having a general molecular formula CnH2n plus 2. Now, this is the key. For every homologous series, for every families of compound, it is vital to have a good understanding of the formula. We have a general formula. With the help of this formula, you can draw the structures of series of members that belong to that family. And that is one of the keys. That is one of the ways I easily figure out the diagrams, the organic compounds being drawn. For example, in this case, in the alkanes, because I know that the formula is CnH2n plus 2, where n is greater than or equal to 1. So for successive number of n substituted into this formula, I could generate the members of this family. For example, when n is 1, when n is equal to 1, it's simply obtained by substituting 1 here. So I'll have C1, which is C H 2 times 1, because n is 1, 2 times 1 is 2 plus 2, that makes 4. So I have CH4. A good understanding of the formula will help me generate the compounds that belong to the alkane series. CH4 is simply called methane. That is the first member of the alkane, CH4. Structure can be drawn in this manner. One carbon bonded by 4 hydrogen atoms. 1, 2, 3, 4. Now each of these represents hydrogen. So this gives us the structure for methane. When n is 2, I simply substitute 2 here. I'm going to get C2. When I put 2 here, I have 2 times 2, which is 4. 4 plus 2 makes 6. So that makes C2H6. This is the second member of the alkane series, and we call it ethane. A 2 carbon atom compound, 2 carbon atom and 6 hydrogen. Ethane is simply drawn from the structure, from the formula. We have 2 carbon atoms bonded by 6 hydrogen. We have 1, 2, 3, 4, 5, 6. Each of these carries a hydrogen atom. This is the formula, the structure for ethane, C2H6. A good understanding, like I said, of the formula, general formula, will help you to draw as many structures as you can think of. Now, considering hexane, the word hex has to do with 6. So let's say when n is equal to 6, substituting 6 here, that gives me a C6. Put 6 here. 2 times 6 is 12 plus 2, that makes 14. So I have 14 hydrogen. C6H14 simply represents the hex, the hexane. So just join the structure of hexane goes like this: 1, 2, 3, 4, 5, 6, 6 carbon atoms, each of which is bonded by a hydrogen atom. We have a hydrogen atom attached to the carbon. Hydrogen in all of the carbon, making C6H14. For each of these, like I stated earlier, CH4, many times This will also be written as CH3, 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 which makes this pair CH3, which is CH3. For hexane, we can also write it in this form, carbon bonded by 1, 2, 3, so we have CH3, carbon bonded by 2, we have CH2, we have CH2, we have CH2, we have CH2, then we have CH3. Considering this, the number of CH2 we have 1, 2, 3, 4. So I can also write it in this form, CH3 twice and then CH2 4 times. Automatically, this is simply in condensed form, that is breaking down each of the bondings with the carbon atom. This is how to write formula for the Alkane series. I'm able to do this because I understand the general formula. I know and understand the general formula. So with the help of the general formula, you can draw any of the structures for the Alkane series. And they take after the name AIM. So that makes them to be a straight chain. In this case, carbon, they have a carbon to carbon bond. I'm sure this video is helpful to someone out there. If you're new to this channel, please do well to subscribe to my channel. And to my returning subscribers, I will always say thank you for showing up. Expect other homologous series. See you next time. Bye for now.